Hello, grade 10. Today I'll be doing the week 11 CA quiz. I'm pretty sure this is like the last one, or maybe there's one more next week, but we're like right about the end of the term and also the year, not the academic year, but the year. Anyways, let's get started. This is not like, there's just integration now, and it's not as complicated as it sounds. So let's begin. Let's begin. We have 4x squared minus 3x cubed, and they want us to find the nature of like how x approaches when we want y to increase or decrease. So here, when they say tends to, that means they're talking about asymptotes. And over here, we don't see any square roots, or we don't see any fractions like without the variable inside the denominator. So that means we can already rule these two out as wrong. Now there's just a decreasing and increasing of y, like in the case of when x approaches minus infinity or plus infinity. To determine this, we have to focus on the coefficient and we have to focus on the highest exponent and its coefficient. So minus 3x cubed. So for examples, we'll take minus 3x cubed and we'll take a base number. Let's say, okay, 0. And then we'll go minus 3, we'll increase like x, we'll increase the x. So what happens when we increase the x? From here it will go from 0 to minus 3. What happens when I increase the x, which means that when x is approaching plus infinity, or any value is just positive and just increasing, what happens? The y also, what happens to the y? It decreases. Now, let's say that we were to bring it down a notch. So like we went from this to minus 1 instead of 0. What would happen? It would become 3. 3 is greater than 0, meaning as x approaches minus infinity, or values that are negative or decreasing, y will approach plus infinity. When I say y approaches plus infinity, what they mean in the options is increasing, and of course the opposite for this one, this is decreasing. Okay, so you just have to remember x goes to plus infinity when it decreases when x is going plus infinity, and increases when x goes minus infinity. Moving on, this is really easy. We first have to remember the rules for the asymptotes to get the horizontal asymptotes. However, vertical asymptote is super easy. We just look at the denominator and we look here. Denominator has variable. The denominator must not equal to 0. We factor, then we get x minus 8 or multiplied by x plus 8. Must not equal to 0. So that means x equals 8 or x equals minus 8. They are our vertical asymptotes. And to get the horizontal asymptotes, we'll do as the numerator 8x plus 0 over x squared minus 64. The exponent here is higher by 1 than the exponent here, meaning that horizontal asymptote will always be 0. I wrote it over here wrong. I put x equals 0. I meant to put... No, actually, yeah, it is x. Over here, y is equal to 0. So here you go, yeah. Y is equal to 0 for horizontal asymptote, since as x approaches plus minus infinity, y approaches 0. So now we can write as our vertical asymptote x equals 8, x equals minus 8, and our horizontal asymptote will be a y equals 0. Over here, we have this cubic function. Over here we have this cubic function with one root, so we have to already distinguish what we notice here. Let's look here. We have an inflection point over here where the concavity changes from pointing down to pointing up. We have to remember the x coordinate. Remember it, minus 1, since I won't be going scrolling down and then back up. So minus 1 is our inflection, like the x coordinate of our inflection point. And there's only one root in this cubic function, which is x equals minus 3. So first, that means out of these, we have to do process of elimination and see which of the following are possible functions, and then we we'll continue onwards. We'll start with roots, which is the easiest to distinguish. Over here, the root here is x equals 3 only. Root, what I mean by root is the x-intercept. And the x-intercept of our goal is to have x equals minus 3 as the x-intercept. And x equals minus 1 as inflection point. Okay, so here x equals 3 does not match this, meaning that this is not possible. So we can discard this as our options. Now over here, there's roots minus 3 only, which means that yes, this is very possible. It has an x-intercept here of x equals minus 3. So this is very possible. Over here, it's x equals 3 and x equals minus 3. Although it has x minus 3, there's also x equals 3. And over here, there's only one root, and that is x equals minus 3, meaning that this is not possible. Here, x is equal to minus 3 as a root, which means that this is also another possible one. So we can now discard these two. These two are wrong, guaranteed. Okay, so let's look here and see what else we can do. Okay, so now what I did here is I expanded two possible formulas of this function. So now this is supposed to be equal to fx. And we should remember here, we already confirmed that these two have a root of minus 3, x equals minus 3. However, we also have to include the fact that this function also is supposed to have an inflection point of x equals minus 1. So how do we acquire the inflection point? You have to first find the second derivative, and we must set the second derivative equal to 0. So let's first derive it twice. Second derivative means we must derive twice. We will ignore the constant since the constant just stays constant. So we'll derive once, so y prime, it will become 3x squared plus 9x plus 9. And we'll derive once here as well, and we'll get 3x squared plus 18x plus 27. Then we'll derive one more time to get the second derivative, and we should get 6x. I put 9 here, I was supposed to put 6x. 6x plus 6. And over here, 6x plus 18. And now we'll set the second derivative, which is y double prime or f double prime x equal to 0. Over here, the inflection point will then be x equals minus 1. Well, over here, the inflection point is x equals minus 3. Over here, our target is to get x equals minus 1. This one acquired x minus 1, so this is the answer. However, this one got x equals minus 3, which makes this all wrong, meaning that the second one is the correct answer. Okay, now over here we must know we must know how to integrate, which obviously, like, I'm sure that most of you have been learning already. Majority, for 2 weeks already. Here, integration, I'll breeze through this. So first here, we'll just simplify this into one line. So integration, sorry, it's not really nice. 40x 2x power of 2 minus 1 to the power of minus 2 dx. Now let's look here. We can take anything from here and call it u, mainly just a polynomial from here. We can take this for examples. So we'll say u is equal to 2x squared minus 1. And then we'll integrate it, du over dx is equal to 4x. Now, what we do next, we must get dx in terms of du, and of course x. So we'll just isolate dx. We get du over 4x is equal to dx. So now we have this to replace with this. Let me just substitute, and I'll write du over 4x. And we'll just substitute here u. So we'll put u here, put u. And we'll just cancel here. We can do cancellation here. This will become 10. This will become 1. So finally, just removing all this. After removing all this, we should get... I don't know why it's always like this. So sorry. Okay. So 10 u power minus 2 du. And now we'll just do simple integration here. We'll put the 10 out for now. U minus 2 du. So it will become u minus 2 plus 1 over minus 2 plus 1, which is u minus 1. So 10, after you multiply with the 10, of course, you'll get minus 10 over u. So now you have this as our indefinite integral in terms of u, and we know that u is equal to 2x squared minus 1, so we'll put 2x squared minus 1 as well. And now what we'll do here, they're asking for w0 and w minus w1. So we'll just get w0. You put x equals 0. So you set w for 0. So you get 10 over 10 minus 10 over 2 multiplied by 0 minus 1. You get 10. So w0 is equal to 10. While w1, to get w1, same thing, but now set it to 1, set x to 1, and you should get, instead of 10, minus 10. Now, I know, maybe some of you guys look through and realize, oh, Amir must have forgotten the constant. There's supposed to be a constant, yes. We're supposed to add plus c. However, when we're substituting, what we do, we cancel, they already explained it to us here, right? This and this, they cancel out. Let's say I did actually add the c, yeah? We'll just add the c for now, right? 10 plus c plus c. And now they're asking, so plus c, and here it's going to be minus 10 plus c. And they're asking w0 minus w1. So we'll just do 10 plus c minus 10 plus c. And then eventually you'll get 20 plus c minus c. These two will cancel, you just get 20. So our answer is 20. And for reference, another way to do this is to just also put 0, like 1 to 0. And then put this. And then you can also solve from there. And do the u method from there too. However, right now, this seems like a way to do it. I'm just doing it as this explains for now. So our answer is 20 here. Now over here, this is where some might fumble. Over here, y is equal to x minus x squared over 2. Not, to be specific, it is not x minus x squared over 2 like this. It is instead x minus, and then separately x squared over 2. This is what they want. This is what I got a mistake on because I didn't understand this one fully. Only because of this. Only because of this part right here. But you have to read it carefully. Hopefully, inshallah, it won't come like this in the exam. They won't mess with their brains. I'm sure it won't come like this. But if it does, you should just always keep in mind that it's x squared over 2, not x minus x squared over 2, entirely. Okay, now over here, what we have here is 2 regions. Now, why I'm saying 2 regions? Because one is in the negative y, while one is in the positive y. When we say one's in the negative y, that means when we try to set the range of x values into integration, so let's see here. Let's say you try to do integration 0, 3, and then whatever the formula is, I can call it fx, I guess, dx. This will not be allowed. Why? Because there's 2 separate functions here. There's this one and there's this one. So this is why we cannot do this way. Instead, you have to cut them into 2 separate regions and then add the regions together, and then you have to put absolute value on on both separate integrations. I'll show you what I mean later on. Okay, so the formula is again x minus x squared over 2. So let's look here. Let's find it like this. We'll just keep a note x minus x squared over 2, and then we'll start to finding this integration here. We'll call it a1, and then we'll call this a2. Now, you know what? I'm gonna call it in absolute values a2. Why? It's because when it's under the x-axis, that means a2 it will normally show as negative. So you have to put it in absolute values to get the actual area, because area can never be negative. Area mustn't be negative. It's always positive. Okay, so now let's look here. Integrate first we'll find the integration over here. We shouldn't be like, we don't need to put like absolute value here. So range values, it goes from x0 to x2, so 0 to 2. And then we'll put the formula in here, x minus x squared over 2 with respect to dx as a1, of course. And then a2 will be in absolute values 2 to 3, 2 to 3. It will be 2 to 3, and then the same formula, x minus x squared over 2 dx. And then you just add a1 plus a2. Keep in mind whether they were already asking for the like total area of both shaded regions. a1 plus a2 is equal to the a total. Okay, let's first integrate the inside and then we'll substitute. Here, fortunately, they gave us two separate terms, so we'll just integrate both separately. We get, we'll just integrate this here. And normally when there's definite integral, we don't really have to apply the plus c. This is gonna waste your time and we don't need to do all this. So let's quickly integrate x. So x power of 1 plus 1 over 1 plus 1 minus, and later like in the following questions I won't be doing this because come on, simple addition, anyone could do it in their head. And you get x power of 2 over 2 minus x power of 3 over 3. Okay, so we have this now, and what we do with this, wait, I believe I made a mistake here. No, I didn't, sorry. So again, once we integrate it, we got 0 to 2 and absolute values 2 to 3, x minus x squared over 2, x minus x squared over 2, dx. Okay, so guys, yes, I did a mistake. Yeah, sorry. I cannot include this constant over here. I did include this constant. I don't know why I did. Or I actually did forget to include the constant, so I'll just separate it away. 1 over 2 is the constant, by the way. X squared over, out of minus x squared over 2, minus 1 over 2 is the constant. We have x squared over 2, and we get x cubed over 3, which is x to the power of 2 plus 1 over 2 plus 1, which is 3. And then we should get as indefinite integral without constant c. We should get x squared over 2, and then separately minus x cubed over 6, since 2 times 3 is 6. Okay, now with this, we'll just subject this integrate indefinite integral to values between 0 and 2, and then we'll just subtract them. So you do highest minus lowest with highest value x over 2 minus 2 to the power of 3 over 6 minus, and then you just substitute 0 and you get 0. So you just do this separately over here. 2 power of 2 over 2 is 2, and then 2 minus 8 over 6 is 2 over 3. So 2 over 3 is a1. This is a1, and this is a2. So we have a1 equals to 2 over 3. So now we know this is 2 over 3. And then over here, we'll do the same thing here. Now, fortunately, they're both at the same thing here, so we do not have to integrate, like do an indefinite integral again. We have it right here. Sorry, we have it right here. So we'll just again write x squared over 2 minus x cubed over 6. And then we're going to subject it to values between 2 and 3. Now when we substituted 2, we got 2 over 3. So first we'll substitute, of course, 3. And remember, in absolute values, of course. 3 power of 2 over 2 minus 3 power of 3 over 6. And then we'll subtract it by, when we substitute 2, we get 2 over 3. You do 3 power of 2 over 2 is 9 over 2, so 4 point. So 9 over 2 minus 27 over 6 is 0. So you get 0 minus 2 over 3 in absolute values, which is equal to just 2 over 3. So now we know a2 is equal to 2 over 3 square units. So now we know that this is also 2 over 3. And since they want the total area, we just add this with this. So a1 plus a2, or to get a total, or 2 over 3 plus 2 over 3 to finally get 4 over 3 square units. So they said k over 3, which is, and then k is just going to be 4. Okay. Over here, they're not asking for area. They're just asking for the definite integral. So even if it's a negative, let it be negative. They're not asking for the area under the curve. They're just asking for the definite integral. So we'll first integrate the inside. We get x power 4 over 4 minus 15. And then we'll just integrate. Well, we're going to leave out the constant. We're going to get x power 3 over 3. And then you just do cancellation. You get x power 4 over 4 minus 5 x power 3. Yes. And then now we'll just subject it to values in this integral, minus 2 to 2. So minus 2 to 2. And then we'll get, we have to do highest minus lowest. So just give me 1 second. So we'll just set it to x equals 2 and then subtract it by minus 2 to the power 4 over 4 minus 5 to the power minus 5 multiplied by minus 2 to the power 3. And then on the calculator, you get minus 36 minus, and like plus minus 44, and then you should get minus 80. So minus 80 is our answer for our definite integral over here. Okay, moving on. So everything over here is under the x-axis, meaning that everything here, like, we expect to be negative. So we want to put everything in absolute values if you want to get just the pure area, the definite value of the area. So let's integrate. Okay, so I just labeled the formula here so then I can scroll down and get a better look at the graph and the question. So if its area is expressed at, as k over 5, then, okay, so we just find the area under the region. So we have the formula here, we just integrate it and then we're going to set the values x from 0 to 4. So we integrate 0 to 4, and then put x power 3 over 4 minus 2x 3 to the power of 3 over 2 with respect to x. Okay, now we just integrate the inside, we get 1 over 4, we leave out the coefficient, we get x power 4 over 4 minus 2, and then x power 3 over 2 will just become x power 5 over 2, since 3 over 2 plus 1 is 5 over 2 over 5 over 2. We will simplify this, we get x power 4 over 4. We reciprocate the denominator, we get minus 2 to x power 5 over 2 is x squared, square root of x over, yeah. So this is going to be our integrated formula, and then we'll just set it to our x values. And in always we put it in absolute values when it's under the curve. It's under the curve. Sorry, I mean not under the curve, when it's under the x-axis. When it's under the x-axis, in absolute values then. So we get the definite area. Now we just do method of substitute. Now we just, no, what method of substitution? Sorry, just substitute. You just plug in 4, power 4, over 4, minus 2, 4 squared, square root of 4, over 5, minus 0. Because if you plug in 0, you guessed it, the value will be 0. So 4 power 4 over 4, minus 2, 2. You get... Now, okay guys, sorry, I made a mistake here. You're supposed to put 16 in here because I forgot to multiply 4 by 4 here. And just to simplify it, we'll just multiply 2 by 2 here and we get 4. And we just get 4 here. 16. Okay, so now we'll simplify it again. Okay, and once everything's done, you should get minus 48 over 5 in absolute values, which is equal to 48 over 5. Which means that that k value over here, k is equal to 48. Okay, so 48 over here. Okay, moving on. So over here, super simple integration. I we'll just quickly breeze through this. So we'll just integrate first the inside. The integration of 10, you just add x in this case. This is a definite integral, meaning you do not need to add. It's no need. You don't need to add. But see, it's not wrong, but you don't need to add it. And then you just substitute 10 multiplied by 5. I mean, set the values first and then do 10 multiplied by 5 minus 10 multiplied by 2. You'll get 10 multiplied by 3, which is 13. So, yeah, 13. Okay, now the area of the region enclosed by the curves. Okay, now over here, it might look simple. It might look like we just need to integrate from values, God knows what. No, we have to draw the graph. Imagine it sounds annoying and it sounds like too much work. It's so much easier than it looks. We just have to apply what hopefully you guys listen like in grade like 9 to your teachers. I don't know why. But I'll just quickly draw it for you. So we have parabola. Over here it's positive, of the highest power, like x power of 2. It's positive, meaning that the parabola is facing upwards, and it's multiplied by 2, so you know it's going to be a little more slim, and it's not intersecting the x-axis. Since it's facing upward, then its turning point I think is 1 over, like x equals 1 over 4, and the y is positive 2. So yeah, x is minus 1 over 4 for the turning point. And then we have just another line with a negative slope, meaning that it's going downwards like this from here. So it's going to go kind of like this. And we should be aware that I'm sure that most of this is occurring. This is not perfectly to scale, guys. Just remember, this is not perfectly to scale, but I do know for sure that this is above the x-axis. This is all occurring above the x-axis. This is above the x-axis, so y plus. So, yeah, there you go. So they want us to find the area enclosed. They want us to find this. Now first, we want to find the x-coordinates at which these enclose from. How do we do this? We do y equals y, or like this is equal to this. So we do 2x squared plus 1 is equal to minus 2x plus 1. And then you get 2x, and you just cancel the 1. You get 2x squared plus 2x equal to 0. And then you just factor out this, and you get x intersects at, they both intersect at x equals 0 and x equals minus 1. So over here they intersect at minus 1, and over here they intersect at 0. So I'm just going to assume that this is the origin. No, this is not the origin, but this is definitely occurring somewhere in the y-axis. Not somewhere, on the y-axis. So over here is our y-axis, not here. So yes, now we just integrate, since this is all above the x-axis. So yes, now we are confident that we can just integrate simply from lowest to highest, so minus 1 to 0, and then we just put the formula. Now over here, instead of being bounded to the x-axis, it's bounded by 2 curves. When it's bounded by 2 curves, we have to do the upper curve minus lower curve, like formula of upper curve minus formula of lower curve. You're like, how do I say this? Like, you're finding area under just the line subtracted by area under just the parabola, and then you should get this little region here. So upper, which is just the straight line minus 2x plus 1, subtracted by the parabola's formula, and then you get minus 2x squared minus 2x with respect to dx, and then minus 1 0. We just integrate the insides, easy enough. You get minus 2x power of 3 over 3 minus 2x power of 2 over 2. You integrated it, and then you get minus 2x power of 3 over 3 minus x power of 2, and then you put the range values minus 1 to 0, and then you begin to substitute. So Okay, and once everything's simplified and done, you put 0 into x, and then you get 0, of course. You put minus 1 in here, and then in total you get minus minus 1 over 3, which is basically just positive 1 over 3. So this is your answer here, 1 over 3 square units. Okay, now next we have just simple integration here again, and this time this is of indefinite integrals, meaning in this case we have to definitely add constant c. So let's look here. We will integrate the exponent. Over here we just simplify it into fractional. We get 70x squared multiplied by x half, and then x to the power of half, and then you just add the exponents since they're both they both have the same base. We have x to the power of 5 over 2 as our initial y, and then we integrate it. So we leave out the constant, and then we have x to the power of 5 over 2 over 5 over 2 plus 1. Sorry, I forgot to add plus 1. And then you get 70. Once you simplify everything, of course, you get, I'm sure, this. Yes, you get this. You then and then you just simplify everything. Sorry, I did a mistake here. I was supposed to put 7. And then you cancel, of course. And then you get 20x power of 7 over 2. And then we'll put it back into standard form, which is 20 x power of 2, not 2, sorry, 3 square root of x. Okay, so that means this we're just gonna reapply like the chain thing that we had. We put 5 over 2 here like we did here. And then once we integrate it, we got 20 to x to the power of 7 over 2. Oh my god, I forgot plus c. And then over here you have to again add plus c. Don't make the same mistake as I did. Over here, same thing. Except now they want it in the normal form, so same thing I did here. And of course plus c. So let's substitute everything here. 5, 20, 7, 23. Okay. Moving on. So we just have integration here. Again, simple, indefinite integration. Now here you do not have to use any u method or any substitution method. Here you can literally just divide by 2 over here, and then you get 150 x squared plus 12x with integrated with respect to dx, and then you get I won't waste my time here. You can do this mentally as well. I'll just do this for you here. X power 3 over 3 plus 12 x power of 2 over 2. With simple simplification, you get 50x power of 3 plus 6x squared plus c. Okay, so 6, 3, 50. 53, 6. Okay, now over here, again, simple indefinite integration. You put x power 4 up, so it becomes 120 x power minus 4 integrated with respect to x. And then you get 120 x power of minus 3 over minus 3. You get minus 40 and then a 1 here, and then you get minus 40 x power of minus 3 plus c. I didn't need to add that, they already included that there. But do not forget to include it when they did not include it for you. Especially in the written exam. Over here, they already derived it for us, so we know. But just in case, not just in case, we must write the table of variation. So let me just quickly draw it right here. We must set the derivative equal to 0 first. We have x minus x and 2. Okay, and then over here, we just do normal substitution, like when we put like any value less than minus 6 minus 7, for examples, it stays positive. derivative stays positive, well, that means y increases. Over here in between, it's negative and it decreases. Over here, it's positive and it decreases. So this is how it is, which means when they say it like this, that means it means between. When they say between, you have to look in between. Look over here. This region over here is between. Let's see. Between -6 and 2, what's happening to the y? It is decreasing. Meaning that it is decreasing over here, decreasing for -6 and 2. The between thing is more extinguishable. You see, you can extinguish this and you can tell, wow, this is between. This means between. Okay, now over here is the opposite here. It increases for the outer sides. For when x is less than -6 or when it's greater than 2. So we put -6 here when x is less than -6 or greater than 2. Okay. Okay, and now over here, on our table, I'll just quickly redraw it again. Over here, -6, 2. It was, if I remember, it was like this, and it increased. So over here, that means it's maximum, or at least x -6 is local max, while over here it's going down to up, meaning that x equals 2 is local min. So let's put here -6 for max, and when we substitute -6 into the original formula, we get 256, and when we substitute x equals 2 over here, you get y as 0. Okay, this question is easy enough. Now over here, I'm sure over here they tried making us use integration, but they nearly gave us everything that does not require integration. They just gave us the answer basically. So over here, they gave us already they literally gave us a stationary point and the point on the graph. This is perfect for us. This is like the key to everything. And they gave us the second derivative too. They made this question really easy. So over here, even if we don't know what this is, we have a point over here, x3 minus 9x squared plus 24x minus c, which is our unknown constant, is equal to y. Over here, when x is equal to 2, y is equal to 3. So we substitute 2 power 3, which is 8, minus 9 multiplied by 2, 36 plus 48 minus c equals y. And then if I put this on my calculator, I get 20. Yes, I get 20 over here, and then once I get 20 here, 20 minus c is equal to 3, of course. That means c is going to be 17. Or this unknown constant will be 17. X coordinate of the point of the local minimum of the curve, so how do we find the minimum or the maximum? We can use the second derivative here. But, however, we can just derive this as well. We already have one stationary point. We don't know if it's... How do we determine if it's maximum or minimum? We substitute the x into the second derivative. So 6 multiplied by 2 minus 18. It is less than 0. When it is less than 0, that means it is concaving downwards, meaning that it is maximum. At x equals 2, it is maximum. Now, to find the other point, we'll just derive this, and then we'll set the derivative equal to 0. So 3x squared minus 18x plus 24. Okay, so x squared minus 6x plus 8. You get x minus 2, x minus 4 equals 0. So, and then, of course, 3. And then x is equal to either 2 or x is equal to 4. Okay, so we already put x equals 2 here, so the only other option for the other stationary point, which is the local minimum, is x equals 4. So over here the minimum is 4, and the maximum is 2. We're nearly done. Over here we're integrating, we're just integrating, and then we substitute. Okay, so to integrate the inside, we can just integrate two separate terms, thank goodness. No need for substitution method. It's not hard, but what I'm saying is it's a lot easier to do it this way. So 40x minus 3 over 2 over... Oh, I accidentally subtracted by 1. It's supposed to be 1 over 2 simply, because minus 1 over 2 plus 1 is 1 over 2 over 1 over 2 plus 10 x power 5 over 5. 1, 2, 8. And then you get 8x half plus 2x5. Okay, and now you have, and of course plus c. Now I didn't forget, which is good. I forgot to put dx here. And now we have fx here. However, we don't know what constant c is. How do we find constant c? In order to find constant c, they gave us a point, and using this point we can find out what this constant c is. So we just substitute here, and then we get, and then c should be 10. So because you get 10 plus c is equal to 20, c is equal to 10. So now we know that 8 squared of x plus 2x power 5 plus 10 is equal to fx. And now they want x as 4. Sorry. So we do 8 squared 4 plus 2, 4 power 5 plus 10. So 8 times 2 plus 2 times 4 to the power 5 plus 10. 2074. Over here, 49x squared, square root of x. So we first put this into fraction form, like the exponent to fraction form. X power of 2 multiplied by square root of x. You add the exponents and you get, I keep on putting 40, it's 49, sorry. So it's going to be x power 5 over 2. You integrate it with respect to x and you get, so 49 x power of 7 over 2, since you add 1 over 7 over 2. And then you get 49, 7x, no, 2x, 7 over 2 over 7. So 1, 7, so you get 14 x power 7 over 2, which is in total 14 x cubed square root of x. So the blank is 14. Now over here we do again upper minus lower. The upper seems to be a straight line, which is 16x, and the lower is the x cubed. So we have we just do simple integration, because everything is above the x-axis and like it's just simply in like one state, or like where like y is always positive. So we'll just do simple integration here. We integrate. We just do upper minus lower from ranges from 0 to, if you go up, which, you know what, I'll go up for you guys. You will see that over here. It is from x equals 0 to x equals 4. So you integrate from 0 to 4. And then you get, and you have to do upper minus lower respect to x. And then you get, over here you can integrate x squared over 2 minus x4 over 4, 0 to 4. Let me simplify the inside. You get 8x squared minus x4 over 4. And then you just do x4 power of 2 minus 4 power of 4 over 4 minus 0, because when you substitute 0, you guessed it, it will be 0. Like y will, like the integrated y will be 0. So let's just do this on the calculator. $64 is our answer. Over here, again, this is definite integral, not finding area under curve. So a negative or positive, it does not matter. We'll just integrate as is. Over here, this time the lower value is like this time the value with the less value, of course, is under the integral this time and not above. So what we'll do here, we'll just first integrate the inside, which is 2x minus 5, and then we'll integrate it. We get 2x minus 4 over minus 4, and you get minus 2 over x minus 4. You substitute then from ranging values from 1 over 4 to 1 over 2 to 1 over 4. Okay. And mind you, over here I made the mistake when I reciprocated the x bar minus 4 should have become positive. And again, I made another mistake yet again. Sorry. 1, 2, x power 4. And yeah. Okay, and once everything's integrated, you get minus 120. So minus 120 is our answer. Now part B, we just have to integrate this. This time this is valid. The lower value is under the integration sign and the greater value is above the integration sign. So we have to do the substitution method. We take x power 5 as u, so u is equal to x power 5 plus 1, not just x power 5. Then we derive it, so du over dx is equal to 5x power 4. And now we just want to find dx in terms of du, so we just isolate dx, we get this. And then you get 25x power 4. And since already x power 5 plus 1 is u, so we can just put u power 4. And then du, not just du over 5x power 4. You cancel, you have 5 here, and then you just put the constant out, you get power 4 du. However, we don't want an indefinite integral, we want a definite integral, and you cannot put minus 1, 1. Why? Because now we're integrating with respect to u, so you cannot be substituting u and x. So what you do, you just give the x values and you plug them in u. So we have x equals minus 1 and x equals 1. So u is equal to minus 1 power 5 plus 1, which is 0. So we have 0 as the lower value. And then x equals 1, so 1 power 5 plus 1 is 2. So 2 is our upper value. So now we just integrate with these values, so you get first you have to integrate the inside, of course. Let me just erase all of this. You get u power 5 over 5, ranging values from 0 to 2. And then you get 2 power 5 over 5 minus 0, all multiplied by 5. This is just going to be like excluded. You cancel the 5s. You get 2 power 5, which is 32. 2 power 5 is 32. Over here, we have now, again, you have to draw it again to be sure. But over here, you can literally tell without even drawing, I think. Like you have to, of course, picture it, like depending on how hard you think it looks. If every single value here is positive, and the values here you think can never be negative or can never approach the negative side, that means you should assure yourself that over here, x over here, it will be like facing up and also just not intersecting, or how do I say it? Okay, so again, I keep on making mistakes in explanation, but this is actually not so easy to graph. So we just have to derive here. So then you can get the turning point. The turning point here is 1 over 3. It's a positive turning point. And yes, it is in the positive quadrant, which means the lowest point or the minimum is in this case up here. And that means in this case, the value should be like, the shape of this of this area should be kind of like this. I just shaded it for you. It should kind of be like this. Not exactly, but it should kind of be like this. So, and over here, x should be 1 and x should be 2. So yes, now we can just do very simple integration since this is above the x-axis. So you do 1, 2, 3x squared plus 2x plus 4. You integrate the insides. And then you put the range values from 1 to 2. And then you substitute, you get 2 power 3 plus 2 power 2 minus, subtracted by 1 power 3 plus 1 power 2 plus 4. And then on the calculator you get 1 plus 4 plus 8 minus 6, which is 14. So you get 14. In total you get 14. 14 square units. And then the very final question here, the area enclosed by the curve 6x squared minus 12x. Okay, here you have to draw. Now here I know you have to draw here. Or you have to imagine it, but it depends on how smart you are, of course. Over here, we first have to determine if here it's facing up, if it's like pointing upwards here. You have to look at the coefficient of the height, like the x with the highest exponent, which is 2. Over here, it's positive, meaning it's facing upwards. However, that does not mean that it is not maybe intersecting the x-axis, or doesn't have any area under the x-axis. So let's look here. In order to do this, of course, we have to find the turning point of this thing. It's 12x minus 12, x is equal to 1. You substitute 1 in here, so then you can get the y value of this turning point, and you get minus 6, meaning that over here, the turning point is something like this. It should be like this, I think. Okay, sure. We're intersecting, of course, the x-axis here and x equals 2. Okay, so now I think what they're asking for here is to find the area under. Oh, well, over here, yes, you do, like, just in case you have to do this for like cases like this where it might intersect, like where you might have to find area under the x-axis, but in this case you don't. Of course, you do not depend off luck, right? You do not depend off luck. And let me just extend this parabola. So like, let me just, like eventually it will reach x equals 4 here. Over here it's 4. And then it intersects x equals 2, which is the closest to 4. And they are just going to be finding this region over here, bounded to the x-axis. Okay. So, over here we have line x equals 4. And okay, super easy. So we just integrate from 2 to 4. 6x squared minus 12x dx, with respect to x, in other words. And then you integrate the inside, you get 6x cubed over 3 minus 12x squared over 2. Cancel. You get 2x cubed minus 6x squared, and ranging from values 2 to 4. Substitute, you get 2 power 4, 2 multiplied by 4 power 3 minus 6. And then this, and then subtracted by the same thing. And on the calculator, you should get, and once you integrate, once you I put this into the calculator, you get 40 square units. And as you can see here, every single answer here is correct. Now, I did take extra long on this, but I know it might have taken really long, but what I recommend you do, like when you watch my videos, you can 2x the video, and you can speed up the video, and I promise you'll still understand it. It's understandable, trust me. Just speed up the video so then I don't take up too much of your time if, of course, you don't understand the whole quiz. And if you want like a full-on explanation of the question, then you can just move to each separate, you can just find me solving a question, and then I'll just explain it from there. Or just speed up the whole entire quiz. Just speed up the video if you need me to explain everything as quickly as possible. And it will still be understandable. Hopefully I helped you hopefully this will help you out, and I hope you do great in your AMS, guys. Uh, Good luck.